So if we want to understand the state of our developer toolchain on CI, so we can then make informed decisions, what to keep, what to improve, we need to collect deep build data first, right? So we can make informed quantitative decisions, right? And that's really what I want to go into in the next half hour. 3 sections: capturing the build data on CI. As I said, we need the data first. Processing the captured data. And then once we have the data, surfacing the interesting insights, which is the cool part. So once we collect all the data about the CI builds, we can then start asking questions about performance. Where are things fast? Where could they be faster? So where is the potential? What is running reliably? What is not running reliably? Why could it run reliably? Are we making good use of our resources? Are we wasting resources? And so on. That's the motivation to get the data about all builds run on CI and not just very selectively for certain projects. We have 2 basic approaches, I would say, about how we can collect data, all the build data from CI. And one is we can go into every project that we run and we can instrument the build such that data is captured and published to a server. Now, if you have hundreds or thousands of projects like we just saw from JPMC, that can be challenging. It's absolutely doable, but as a CI person, you might want to move forward faster, right? You want to have the data as soon as possible and not go through a gradual adoption, even if it's a fast adoption. Why is it a bit slower? Usually you need to get the buy-in from the product owners and you need to make a build modification. It's very small. It's usually a few lines of code in the build, but still you need to touch that build. And maybe it's a project that isn't even run on a regular basis anymore, so nobody really wants to touch that project anyway. So, and also there's another problem, or there is a problem, like if you have 1,000 or 100,000 projects, which ones would you reach out first and ask, hey, can we connect the build so we get the insights? Because if you don't have any data, which are the most relevant projects, which ones are you going to reach out to? All right, so we really need some data first so we can make informed decisions where to invest our time. The alternative is that we have our CI runners, and it could be any of those CI tools, inject the configuration. So you don't need to touch the projects themselves, but from the outside, you configure the publication as well as the capturing of the data, and it is sent to the server. And obviously that means you don't need to touch the project. And that is typically the faster approach to get started. And as a CI person, it's basically all you need, right? You want the CI data. Even if holistically as a company, you also want all the local builds, of course. And that's where you use the configuration of the project. For Develocity, we have plugins for all the major CI providers: Jenkins, GitLab, GitHub Actions, TeamCity, and Bamboo. So if you use those plugins, they will automatically inject the configuration. You point it to the server. All right, so to make this a bit more concrete, one example using Jenkins, but it could be any of those TC providers. You have to provide a little bit of configuration. I'm not sure if you can read this on the screen, but it doesn't matter, because in the end, what you need to provide is the URL to the server to which you want to publish the data. And optionally, you can configure the plugin version or the extension version of the Develocity plugin or extension. If you're a bit uncomfortable to flip the switch and turn on build scan capturing and publication for 100,000 repos, you can also define filters and gradually enable this over time, or explicitly filter out certain projects. Now, and as a nice addition, once a build is captured, in the summary view of all these build tools, you also get the build scan link, right? So you can quickly navigate to all the data, the visualization of all the data that was captured, right? This also, of course, as a nice side effect, makes the developers also more self-serving, right? So they're running the build, something doesn't work as expected. Instead of creating a ticket for the CI people right away, they can first look at the summary. They see, oh, something went wrong. I have a build scan link. They can follow the link and they can investigate themselves. And oftentimes they can find the resolution themselves as well. Right? Maybe a new snapshot version was pulled in, made the build break. CI wouldn't be able or does not need to help with such a problem. Right? For those that understand things better in terms of code, this is just pseudocode. But how does injection work? For Gradle builds, we inject an init script from the runner, right? So we use the existing runner and we just say, hey, here's one more argument, and it points to an init script. For Maven, we add one more system property that defines the extension class path, where we can say we also want the Develocity extension jar to be on that extension class path. And that's it. All right. Before I finish this part, what I can recommend, whether you have a lot of projects or even just a single one, is to have a configuration plugin, convention plugin, where you capture all the configuration, right? So which server, your build cache settings, maybe you capture some custom values and custom tags and so on. Bundle that all up in code in a plugin or an extension, and then inject that to your build. Right? You can even version that, right? It's just a dependency, and then you can make changes, publish a new version. You can even automatically upgrade to these versions, and then everything is nicely bundled. And of course, if you have a lot of projects, they reused exactly the same configuration. We have examples for that are linked here. Right? All right, let's get to the second part. So we are now capturing build data from all the CI builds. Great. Now, if we take these build scans, and you can easily have millions, tens of millions of build scans, and you want to start asking questions about your tool chain, we can export that data into a big data store and ask those questions there, right? So this is an approach that scales. These systems are made to handle this large amount of data and even much larger amounts of data. So what Develocity offers is to export build data via so-called build models. Right? These build models are in JSON format. They have an API specification, with they are described. And currently you can export build attributes, performance models around build caching, and project structure. And over time, more build models will be added. But those are the key ones. You get very far with those already. Those build models are very consumption-oriented, right? So compared to the raw event data that we also expose, those are really meant for others to consume, other tools, or even something you write manually. Those build models are backward compatible, so as we release new versions of Gradle Enterprise, the existing models can still be read, right? We're only adding things, we're not removing things. So there are two ways how you can get those build models out of the system with Develocity. One is you write your own client, right? And you use the API that we offer, and you get the data out this way, right? This works well. Many customers are using that approach, but it means you have to do a bit of work, right? You have to deal with retries if connections fail or timeout. You have to resume things at the right point in time. If you have multiple build scans to get, you have to deal with paging, possibly with parallelizing the fetching, and so on. And of course, you do the ad hoc analysis, or you have to save the data into another store. So there's a bit of getting data and moving data around that you have to manually deal with. But again, it works. People are using it, and they're creating really nice insights from that data. So again, how that would look is you basically invoke the API, you pass it some filtering criteria if you want to, you say where you want to start in time with the builds you want to get, and so on. I'm not saying you should use curl as a client, but it gives you an idea of how you can get to that data. Now, alternatively, you can have Develocity automatically export all the builds that are captured, or more specifically, the build models of those builds. And by automatically exporting them, you can make them instantly available to a big data engine to take that data and work with that data. So the shortcut here is that you can immediately start asking the domain questions, right? And you don't need to deal with all the machinery to get the data and put it somewhere else. I want to make this more concrete with the full flow. So if you have Develocity, you can export the data to S3. So these build models, Develocity will export them to S3. From there, Athena from AWS can consume them. And with Grafana, we can visualize that data by querying Athena. So let's take a look at that in a bit more detail. It's, by the way, also the approach used by JPMC, which we just saw the talk about from Shemba and her colleagues. As I mentioned, you can configure Develocity and say, hey, whenever there is a new build, export all the build models in one JSON file to a stream, and you point it to where you want to export that to. Those models are automatically updated when there's a new version of Develocity with new build models or new attributes on these build models, or even totally new build models. So this happens without you having to do anything manually, right? Which is different to other solutions where you would have to reprocess all the data when there's new data available, right? This is all taken care of. In S3, those build models, they are compliant with this OpenAPI based schema, as I mentioned. All the build models go into one JSON file, so not each build model gets its own JSON files because for performance reasons. They're stored in a compressed format, and they're partitioned by date or by time, right? So that when you do the queries, which are typically for time windows, those big data engines can very quickly get the right window of time and then process the data. So in the end, the way we store it and how we store it and where we store it and in what structure is very optimized for those Apache Hive-based engines that query then the data. So in Athena is serverless. Right? It does a bit of caching of certain queries that you can tell it for how long to cache, but that's it. It has, though, a schema that you need to define. Basically, you need to define a table with a schema, and that schema needs to map the JSON models that we are exporting. And then you can run SQL-like queries against these tables, multiple tables, single tables, and you can join up any build models that you want to combine together. And then the last part is Grafana. So you can define an Athena data source that's already available. And then you create your charts and you just issue the queries that you want to run against Athena. And Athena will then use the data in S3 to present the results, right? And I gave you one little example here. If you could read it, you would see it's very simple and it's very SQL-like, but it will work no matter how many build scans you have in the system. All right, then to close the loop here, if you want to define everything via code, you can use, of course, Terraform to provision the Athena resources, and you can define your JSON dashboards in JSON and import them by any mechanism you already use. Right. What we want to do in the future is that we automatically create the table and the schema for those build models that we export, so you don't have to go through this step. So you upgrade the Develocity to a new version, and it will automatically create that new table and the new schema. And keep in mind, nothing is really stored in Athena, right? It always operates on S3, so just replacing that table with the new schema, nothing is lost. Okay, so we have the data now in the big data system, and now we can surface some data, right? We can identify usage pattern, failure patterns. Maybe things are different on different agents or different times of the day. You might experience flakiness more in some areas than in other areas. You want to know about acceleration potential. Where are you wasting resources, and so on. Right? We can now all ask these questions. And just for inspiration, I created some questions, right, that can be answered. And this one is very basic, right? How many projects do you have? What build tools are you using? How many builds do you have? I'm using the Micronaut Foundation projects here. So only about 80. But this is a question that many companies you ask, they don't know the answer. They say, we don't know. We don't know how many projects we have. We don't know how many builds we produce, right? They cannot answer some simple or basic questions, right? But with this approach, once you have all the data here, you can ask those questions and get very quick answers. But that's, of course, just the beginning. We can also ask questions about build volume, which projects create the most build counts, which add up to the most duration, right? Which means they consume the most CI resources, right? Which have the highest median build time, and so on, right? That already gives you an idea of who are the star players in amongst your projects, right? And they probably need a close eye because they can also do the biggest harm. Right? If they're misconfigured, create a lot of failures, a lot of flakiness, you will experience this much stronger than if it's a project that is not built often. If we look at failures, just again for inspiration, we can look at which projects fail the most, to how much build duration does that add up, right? Because every time something fails, you typically rerun it. So you just wasted a cycle on CI that you could have avoided. Especially, in fact, it's the second point, but it's non-verification failures. Right? It's okay. You're on a build. You want to get sort of verification that it's all fine. But if a test is broken, okay, you want to know that from your tool chain. But if the build is breaking because some system was not available, that is an avoidable failure, right? This is not a verification failure, right? And that can add up to a lot of wait time for you and to a lot of resource consumption on CI. Or maybe you want to see which build agents have the most amount of failures. Maybe you see that there is a imbalance. Maybe some machines should be taken out of the cycle or so. Or there's another reason why certain agents are more unstable than others. Maybe there's too much running in parallel on these machines. And so we can get a good sense for failure-related issues, and they're actionable, right? We can do something about them. And to finish this off, we can also find potential for acceleration improvements, because we all know faster feedback cycles makes us more productive. And this is, again, just some ideas. So if you don't have build caching enabled, it's interesting to know which projects create the most task or goal execution time with those goals or tasks that are typically can be made cacheable. Right? So you take the compile goals, the test goals, the code generation goals. If you use the cache, you could make those cacheable. So you have a lot of potential for savings. So let's see which ones create the most build time. And then those are good candidates for caching and saving time. Or you're already using caching, but maybe there are some builds that add still up to a lot of build time with these three tasks or task types, because there's something wrong with them in terms of cacheability. Right? So then you can do something about it. Or you have projects that create build cache errors. If you have build cache errors, what happens in Gradle and Maven? It turns off the caching for that build. So if the error happens very early, the rest of your build is not using the cache, which is the same as not using a cache at all in that build, right? And I've seen cases where this was not seen for 2 weeks, right? So for 2 weeks, they were basically running without a cache, just because always the first request to the cache was not working because something was misconfigured in access control, right? So it was not a build cache bug, right? It was really a bug in the configuration. Or you have long dependency download times. Right? This is substantial contribution to build times sometimes, and also to the load on the Artifactory or Nexus. Or you have a multi-module Maven or Gradle project, but you're not using parallel, so you're probably missing out on some optimizations. I've seen projects going down by like 20-30% just by enabling the parallel flag. Or you're running in parallel, but you're only giving them one thread for Maven. That's not the point of parallelism with one thread. So, and if you have so many projects, hundreds or thousands, it easily happens that some of them are misconfigured, right? It's almost statistically has to be the case. Or you run Maven projects on CI, but you're not always using the same Maven version. Most projects don't use the Maven wrapper, meaning it just takes whatever Maven version is on that agent. It might not always be the same one, so you never get any cache hits. So these kind of things you can expose, and then you can draw conclusions and take actions. Right? So basically what my take-home message would be is that you capture the data so you can make quantitative decisions, what to improve, and you know where you will have the most impact. Because if you have 100 projects, you cannot fix all 100. So where do you invest your limited time? And by having these top 10 offenders, and you start there, and then you go to the next top 10, you can systematically improve the situation, and you're sure you're always investing your time where you will get the most return. So with that, thank you very much.